Okay, so again, these notes are going to cover some of the areas that you either should have already learned or are learning for the first time, but obviously need to know where to move forward. This is not in your book. This is going to get supplemented by this material, and then you'll get an assignment tonight and a warm-up on Monday about it. So area of a rectangle, hopefully something you know, is base times height. Area of a parallelogram is also base times height. And then area of a triangle, hopefully you remember, 1/2 base times height. So the difference between parallelogram and rectangle when we're finding the area is that on a rectangle, the base and the height are going to be the sides of your rectangle, because a rectangle has 4 right angles. When you get into a parallelogram, okay, which can have, or doesn't have to have 4 right angles. It can, right, because a parallelogram is, or a rectangle is a parallelogram, okay, but if it doesn't have those 4 right angles, then the height has to be found. So this would be the height, and this would still be the base. So the base would still be the horizontal side, okay, and the height would have to be found, and the height is going to be a perpendicular line connecting the top to the bottom. So that's the same formula, but obviously the height has to be found a different way. And then area of a triangle you can get with a right triangle where this is your base and this is your height. The side lengths would count as the base and the height. Or you could have any other type of triangle where the height would have to be found using the perpendicular segment and the base would be the horizontal or flat side. Then you've got area of a rhombus, which is 1/2 diagonal 1 times diagonal 2. So if we remember a rhombus, it's a parallelogram with 4 congruent sides, the diagonals. So if this is diagonal 1 and this is diagonal 2, and it doesn't matter which one's which, I'd multiply them together and divide by 2.
So would it be the whole diagonal?
It's the whole diagonal times the whole diagonal times 1/2. So first identify what kind of shape it is. If you look at A, what kind of shape is that? Parallelogram. Okay. So I know that the area is going to be base times height. The base being the bottom. If this segment's 2 and this segment's 10, then the whole segment would be 12. And then I need the height. So this time, is the height given to you? No, I have to find it. So this little segment here is my height. By drawing that, what have we just formed inside that? A triangle. What kind of triangle? A 30, 60, 90 triangle. So it's a right triangle because this is going to be perpendicular if it's the height, okay? They're telling you this angle is 60 degrees, which says the top angle's got to be 30. And then, lucky for us, we just reviewed these, right? 30, 60, 90 triangle. Opposite the 30 is A. Opposite the 60 is A root 3. And opposite the 90 is 2A. So this 2 is opposite the 30, which means that's the A. The height is opposite the 60, which means it'd be what? Good. 2A square root 3 or 2 square root 3. So now I've got the base, which is 12, and the height, which is 2 root 3. Multiply that out, and I get 24 root 3. It didn't give me a unit, so I literally used the word units squared. So the same thing's going to happen for your test that happened for your quiz. There's going to be some questions you're going to use your calculator to get a decimal, and then there's going to be some that you leave exact, or in terms of pi. Exact means that root 3 stays root 3. This would be my answer. If it said to the nearest decimal, I would then take 24 and multiply it by root 3 and round it. Okay? So you want to kind of go back and forth between the two. Alejandro, you're good?
No.
Okay. Okay, B, what shape? Well, it's missing the little things, but it should be a parallelogram, okay? So again, I know area is base times height. The base, this time the 9's on top, that 9 is floating in the middle, so I know this is the whole base. It gives me this angle here is 45. So if I drop down my line to make my height again, now what kind of triangle do I have? 45, 45, 90. And the relationship there, oops. A root 2. Good. So 45, 45, 90 is A, and A root 2. Which means opposite the 45. This is 45. This is going to be 45. Obviously not drawn to scale, but you get the idea. This would be A. This would be A. And this would be my A root 2 side. So if A, God bless you, root 2 equals 6, I would divide both sides by root 2. A equals 6 over root 2, rationalize it, and I get 6 root 2 over 2, which is 3 root 2. So that is this part, and it is this part, which is what I'm looking for. So do I have base and height now? Alexis.
No, we already know that, but is there an easier way to get from there? You see how you did like almost by your times root 2 over 2?
Yeah, I mean you have to rationalize it, but when you're dividing by root 2, if it's an even number, you're always going to cut it in half and multiply it times root 2. It's just not as easy if it's not even. You would leave it as a fraction. So now my area equals the base, which is 9, times the height, which is 3 root 2. Multiply that out, and I get 27 root 2 units squared. Questions on that one? All right, then C. So this would be a little right angle here, okay? And this would be a right angle up here. Area equals 1/2 base times height. Do I have the base? 46. Do I have the height? 12. All I got to do is plug it in. 1/2 46 times 12. And I can do this in any order I want because it's multiplication. So I can either do half of 46, multiply that times 12. I could do half of 12, multiply that by 46. Or I could multiply 46 and 12 together and divide by 2. I'm going to do half of 12, which is 6, and then 6 times 46, 276. This time it gave me a unit, so this would be millimeters squared. One other quick thing I'll add to this is if it's an isosceles triangle. Okay, so if I had the base, I don't know, like was 10, and I had this was 3 and 3. No, that can't work. Hang on. This would be like 13 and 13. Let's say it's that. So think about what we know about an isosceles triangle. If I drop down my height here, what happens to an isosceles triangle when I drop from the vertex angle? It bisects that bottom side. So this is now 5 and 5. And now I've got 2 right triangles. 5, 12, 13 is your triple. So this would be 1/2 the base, which is 10, times the height, which is 12. And it would be units squared. So a property of isosceles triangle that you're definitely going to see again. When you drop a perpendicular line, which is that altitude, from the vertex angle on an isosceles triangle, it cuts the other side into 2 congruent pieces. Questions on that one? Standardized tests love to use isosceles triangles in that way, and they love triples, so it's good to know those things. All right, so this one kind of puts all of it together. This shape is a rhombus. It says in rhombus ABCD. AC is 20, so this segment here, which is my diagonal, is 20. BD is 15, and it says the area can be found in more way than one. And it gives you the area equals blank times 12. So what type of shape is it if I'm going to multiply two things together? Which area formula would that be? Without the 1/2, because 1/2 comes second. A just says blank times blank. Base times height. What kind of shape is a rhombus? It's a parallelogram. So I can also say that this is base times height. If that's the case, the base is 12.5 and the height is 12. Does that make sense? So this is 150. Now we use a half blank times blank. So this is the other formula that we use for rhombus, right? Which is 1/2 diagonal 1 times diagonal 2. Which would be 1/2 of 20 times 15. 10 times 15 are 150. And yes, they should be the same, right? The same shape. And then that last one is saying there's 4 of the same shapes inside this rhombus. What are those shapes? Triangles. So I can also say 4 times 1/2 base times height of one of those triangles. So if I just pick this one on the right, okay, and it doesn't matter which one you pick because the base on one is the height on the other, the height on one is the base on the other. So this is half of my diagonal, which would be 7.5, and this is half of my diagonal, which would be 10. So it would be 1/2 10 times 7.5 times 4, okay, which is going to be 5 times 7.5. 38.5. And then I can even do a half times 4, which is 2. 2 times, wait, that's not right. 38.5 is not right. 7.5 times 5. Oh, I already did a half. I can't do it again. So this is 37.5. And then I already used the 2, or the half, so I can't use it for the 2. I'd multiply that times 4. So depending on what information they give you, like if they only gave you the diagonals, then I'm only going to use that formula. If they only give me the base and the height, then I'm only going to use that formula. I probably wouldn't use the 4 triangles, because you already have the diagonals. Probably easier to use the second one first, but it's also a good way to check it. Yep.
Where'd you get the 10 and 7.5?
It's half of the diagonals. So if I just use one of the triangles, like I just used that one, then I need half of one diagonal would be the base and half of the other diagonal would be the height. But again, if you're given the diagonals, it's way easier to just do a half diagonal 1 times diagonal 2. If you're given the base and the height, it's way easier to do base times height, because a rhombus is still a parallelogram. Questions overall on any of the areas? Okay, so your assignment tonight is going to be like, I just grabbed a handout that we used to use before. It's